Problem 91, we're taking a look at I to some large exponents. All of this is based on the idea that I to the first just equals I squared is a negative 1, I to the third is negative I, and I to the fourth equals 1. That's all from a previous problem, problem 90. So this pattern just keeps repeating. So I want to figure out how many I to the fourths, which equal 1, I can get out of each of these. So for instance, I to the 592nd, well, 592, if I divide that by 4, that ends up giving me 148. So I can rewrite this as I to the fourth to the 148th. And the reason why I do that is because the power to a power rule means I multiply them. So that equals my 592. I to the fourth is 1, so this is 1 to the 148th, which is just 1. So doing something similar with problem B, I go with I to the 797th. Well, 797 divided by 4, that one will not divide evenly. That one is going to be 199.25, which is the same thing as 199 and 1/4 left over. So there's 1 left over. So I can rewrite this as I to the fourth to the 199. That would be 796 I's. So what I need to do is I need to account for that last one. So it's times I to the first. This all becomes a 1. So the answer is just I. Looking at problem C. Perhaps you want to try it on your own quickly. So you could pause this. So I to the 10,648,202. Again, this process right here just keeps repeating. We need to figure out where we end up along that process. So if I do 10,648,202 divided by 4, I end up getting 2,662,050.5. 0.5 is 2/4, so it ends up being I squared. So this is the same thing as I to the fourth to the 2,662,050 times I squared. Again, this part right here equals 1, so that cancels out. So I get I squared, which is -1. Hope that helps.